Right, in 1950s, it took a mechanical engineer. Today, it takes 100 million lines of code. With the advent of smartphones, over-the-air updates, and vehicle-to-everything interactions, cars are becoming more exposed to increasing external cyber threats. Connectivity comes at a price, and consumers are growing their concerns. So the question is, how do we protect? And I'll be discussing it today with the experts and a guest, Markus Janke, Yoni Kahana, Dr. Cedric Levy-Bencheton, and Rossella Mattioli. Markus has been working on conception, development, and realization of standalone and PC-based smart card terminals. His first exposure to security was with a telephone card in Germany. Who remembers the good old phone cards that we used in those machines? After the diploma thesis in electrical engineering, including development, a dedicated PC smart card terminal system, Markus joined Infineon, and he's heading up the security at Infineon, looking at all aspects. If we look at the kind of the chain and the stack of the car, looking at all aspects of hardware. Yoni is the chairman of the security group at the Car-to-Car Communication Consortium, which defines all the security-related issues that comes with the car-to-car communication. He's also a managing director of the cybersecurity group at General Motors Israel, where he is in charge of securing the critical elements of the vehicle. More than 15 years experience in managing, leading, and developing large-scale projects in secure telecommunications and embedded systems from idea to completion in both R&D domain as well as from the business and from the product perspective. He experienced with Fortune 500 companies defining product roadmaps with system requirements for secure features on billion mobile chips and cars. Dr. Cedric Levy-Bencheton is representing the global cybersecurity consultancy IoT Active, and he promotes the need for security in every domain of our society, focused on Internet of Things. He was the expert of cybersecurity at ENISA, the European Union's Agency for Network and Information Security. There, he developed the area of smart infrastructure as well as the concept of security for safety. And Rossella Mattioli, who works at ENISA now, she joined in 2013. I found it very impressive that Rossella actually studied cybersecurity. You majored in cybersecurity at the university, and her work focuses on enhancing the security of the critical infrastructure, IoT, and transport infrastructure in Europe. Along with the thematic reports and community engagement, she coordinates ENISA's expert group related to internet infrastructure, IoT, intelligent public transport, and smart car cybersecurity. Masters in engineering, as I said, with main specialization on cybersecurity. We will have now, as with every discussion panel, individual experts presenting shortly. So we'll start with Markus Janke, who will talk to us about his aspect of hardware security. Thank you.
So thank you for this kind introduction. And so today I would like to start with some aspects, some technical aspects about the security, and would like to go also on the kind of hardware attacks also in the car may happen. Of course, as you have heard from my vita, I have also a very long experience in smart card security, and I think a lot of topics we see in the smart card world we can also transfer towards the automotive industry. So, of course, if we talk about automotive security, we all know those different kinds of headlines dealing with all kinds of security flaws and also with some weaknesses in terms of security. But I'm convinced that this is only the tip of the iceberg. So, if we talk today, we see some attacks on fraud, on theft, on privacy, and perhaps even some mass attacks. But as the car gets more and more connected and more components are inside the car, but also components are communicating with external partners, we will face a lot of scenarios in the future. And here on this slide, I just try to summarize some of them. There are some which are threatening the, for example, car industry, like tuning, so that some features will be enabled even if the customer may not pay for it. But it may also have some severe safety problems, because if the car, for example, the braking system is not equipped sufficiently for the motor and for this engine power, then there might be some very big risk in here. We see also a lot of other aspects where an attacker may influence the car security and try to get some benefit out of this. But it might be also just for publication and for some public interest in here. If we look, for example, on attack on privacy, where someone may spy out at what time a car has been at what location, or for example, if even the hands-free operation from the telephone would be enabled in order to spy out what are the words and the spoken words inside the car. And finally, also, we have, of course, all the kinds of attacks on the persons, or, which is a very interesting scenario, a denial of service attack. Just think about what happens if an attacker can manage to lock out or to jam all the police cars in a town. And then, in a case of emergency, the police cannot use their cars. So from this perspective, I think there are a lot of scenarios we will face tomorrow. And these targets are also today more or less easy to get due to the fact that very often we face inside the car a so-called security by obscurity system. And this is something like if you would use such an artificial stone at home in order to keep a spare key in front of your door. Of course, once it might be somehow secure, but if you know that all the stones look like this one, it's quite easy to look out for this, and once you know it, it's easy to identify. So I think it's more important to have something like Kerckhoff principle, that even if the principle is known, it's well secure. Some examples for such a weak security by obscurity are on this slide. On the left-hand side, you see some procedure in order to manipulate the accepted key for a car. And indeed, you have to open and close the driver car twice. And if you have 2 times the driver's door open and close it again, and several times insert the key into the ignition, then you end up with some menu where you can also change the accepted keys and so on. But also there are a lot of other examples. If we see on the right-hand side the different kinds of manipulation, for example on mileage, or also there are some devices available, for example those kinds of special tuning devices, which in the end just use the security by obscurity as the sensor data will be manipulated, and therefore more horsepower would be gained from the motor. And again, here the risk is if the brake system is not sufficient for this, there might be some danger. So let's think about what might be the attacks of the future. And let's take a look in another area, for example, in a safe. And I have one small one here, because you all know what happens if you want to break such a safe. Of course, you can use a logical attack, try all the combination, the same as we have seen before with the security by obscurity. But you can also use, for example, some brute force, for example, a grinding disc. And with this grinding disc, of course, you can try to open up the safe. You can also try to eavesdrop the combination. You know it all from the movies where you have a stethoscope, but here in an electrical safe, of course, it's not possible with a stethoscope. So therefore, you may use such a receiver, and with this receiver, of course, you can check the activity of the keypad and the microcontroller and spy out the correct combination. And finally, of course, you see here also a small lock, and you can also make some lock picking in here in order to get access to the content of the safe. The same scenarios also apply to electronic components, and so also to the motor electronic or to the components inside the car. For example, we can make some logical attack, not trying out all combination, but just manipulating the best bus transfer and the data on the buses. Or we can make some manipulative attack. That means we can make some probing. I have just an example later on. We can use some observing attacks, spying out the data, for example, if we observe the power consumption. And we can even try to circumvent here something like a lock by using some fault injection. Let's go very briefly into those different details. And on this slide, you see some example for probing on a professional scale. So on the upper picture, you see some professional probing station where you are able even to intercept signals on the ship itself. That means even on the silicon of a ship. But in the lower picture, you see also some example how this can be done on printed circuit board. And I got here also one of a hacker device. With this hacker device, you are capable to collect all the signals, for example, on a printed circuit board, in order to identify what are the transferred commands and what are the transferred data. And this is very low cost. This is about 100 euro available in the internet for performing such a kind of attack. The second scenario would be to induce some faults. And you may also even use electrical impulses. For example, this is an attacking device from a hacker from the pay TV scheme, where a pay TV card has been manipulated. This could be also, of course, used for silicon chips inside the automotive industry if these are not secured sufficiently. Or in the end, we also know that the silicon is nothing else than acting like a solar cell in terms of some optical radiation take place. And so I could use a very simple strobe light, and with such a strobe light, I could easily also influence the behavior of an unprotected microcontroller and change the operation. I have also one example and demonstration here, but unfortunately, due to timing reason, I will skip this right now. If you are interested, we can do this later on also in a small side-up round. And finally, we also have the topic of observing attack. Also here we have either the possibility to use lab equipment with a high-end oscilloscope and so on, but also this could be performed inside a car for measuring the power consumption of a unit and thereby trying to spy out the functionality or the secrets processed inside here. So you see here a lot of possibilities for attackers also in the future, and there are of course also the discussion about some countermeasures. I just would like to emphasize here that it's not sufficient just to harden the software. To harden the software, that's very important for logical attacks, so to prevent protocol attacks and so on. But for observing attack already, you need some basis in hardware, for example, a good random number generator, a good random source, in order to make some randomization of the functions and the calculated data. If we talk about fault injection attacks, it's even more important that you have a hardened hardware which is capable to detect some attacks like this. And latest for manipulative attack, just think about if someone would place some fine needles on the silicon surface, how a software should prevent this. So from this perspective, latest here, we are talking about security devices, and these are very important in order to have an overall security. Anyhow, I also would like to encourage at the end of my small presentation that it's not such sufficient just to build in some measures. It's also important to evaluate them. And we know, for example, in the smart card industry and also in other areas, the so-called common criteria certification, which deals with all kinds of evaluations for checking the level of security. And why this is important, I may also show here with a small safe. So if I open up the safe, you will see that this safe has also some very bold metal locks here, and also it's somehow very good in metal, so yes, it seems to be somehow secure. But let's see how secure this is really, and what you can discover if you make a real security evaluation on such a safe. So I have closed this, and now I try to open this again without typing in some information. And here we are. So I have opened the safe without entering any combination. This is simply due to the fact there's some weakness hidden inside the safe. And by the way, this is also working with bigger safes, but I was not capable to get the bigger safe in the hand-carried luggage, so I take the smaller one. But here on the slides you see also the same example with a big safe, and the weakness is inside there. For extending the battery lifetime, they have used a very small solenoid, which is very weak. And in case I place my fist on the top, it's just vibrating the locking mechanism and releasing here the door opening mechanism. This might be not visible in case you buy such a safe, but in case you make a security evaluation like common criteria, they would also look inside and make a white box evaluation and therefore identify where are the weaknesses. So I would also like to recommend to put those kinds of evaluations for systems like cars in the future. So thank you very much for the attention, and we will continue with the next presentation.
Thank you, Marcus. Yes, Yoni.
This one, right? So until my slide deck will be ready, do I need to do something in order to bring my slide deck?
I think the team will tell us
Okay.
when we're ready.
So until it will be ready, so I'm Yoni Kahana. I'm the chairman of the security working group in the Car-to-Car Communication Consortium. I'm also leading a product cybersecurity group in General Motors. And mainly my presentation will be on behalf of the Car-to-Car Consortium, because I'm going to talk about security and privacy aspect in the car-to-car communication. So first, as a background, to make sure that we are all on the same page, when we are talking about car-to-car communication, we are talking about two ways of communication with surrounding vehicles or with the infrastructure itself. So if later on I will refer it as C2X, you should understand that it's car-to-car or car-to-infrastructure. And it's basically based on the Wi-Fi that you're all familiar, with some customization that's been made to support moving network that, of course, is relevant to the scenario of vehicles. So it's based on the standard of AO2.11, and the P is for the car-to-car communication, which again have very unique network capabilities. And it required high quality of position and timing for the use cases that I will describe in a minute. And for reference, when we are talking about sensors, normally we are talking about something that can reach for around up to 200 meters. And when we are talking about car-to-X communication with one hop, which means directly between two endpoints, we can get to a 400 meter. It can be extended if we are using multi-hops, which means that the endpoint can propagate the information to other endpoints, and then it can reach even to 2 kilometers. Again, for reference, mobile network, of course, can reach over 200 kilometers, and then there are other challenges like delay and quality of service that I won't address in this presentation. So the main driver for car-to-car communication is about safety. In North America, it's the only focus. It's called basic safety messages, And also in North America, you may hear that it's called V2V or V2X, vehicle to vehicle or vehicle to infrastructure. And it's about communication between the vehicles. It's about getting the knowledge of emergency brakes that was occurring beyond line of sight, whether it's because of a corner, intersection, or maybe it was because of a car that you don't see because it's in front of your car in front of you, or other that may occur on the road that you don't see. So in North America, it's basically between the vehicles, and again, very much in focus of course, increase the safety and reduce crashes. In EU, it was also extended to car to infrastructure to support traffic control, to improve traffic control. Once you have a lot of information from traffic to infrastructure, you can of course improve the signing, you can improve the traffic light changes, etc. So in EU, it was extended and also support in the day one use cases, the communication for the infrastructure. So once I describe what's the benefit of car-to-car communication and why we are driven to do this, now I'll talk what are we concerned about, because this is my role. So first, crashes. As I said, the main motivation is to increase safety. But once you have a system that you rely on in order to react, if the information is not reliable, you may even increase crashes, right? Because for example, today, all of us are used that there is a brake light, right, in the car before us. Now, if today the brake light will be broken and it won't signal to us, it actually can cause a crash. Okay, so once we are used to have a sensor or indicator for some behavioral, then if it's not working or it's not reliable, then it may even cross crashes. So this is main concern that we want to ensure that won't happen. Another thing is manipulation of traffic. I said that we want to leverage it to have a better control of the traffic. But if someone can manipulate the information, then of course it can create scenarios, then you actually redirect all the traffic to run route and cause a huge traffic jam, and then may have an empty route, which is great for me when I'm driving to work and I want to avoid traffic jams. I will be happy to leverage it. But of course you can imagine that it's less good for society. Another thing is traffic lights. I think that most of us, where they were standing in red traffic light, had dreamed about they have this mini controller that can change it to green light, and I maybe change it in advance, and then you have a green light wave all the way to where you want to get. Again, great for the individual, not so good for society. So we want to avoid it. And there is also a scenario of emergency vehicle, that emergency vehicle may have privileged capabilities. We want to make sure that only authorized emergency vehicle will be able to do so. So now I'll translate these scenarios on these use cases into technical terms, into security requirements. So we want to make sure that the data that we received is valid, is not being compromised, it's not been changed. We want to make sure that the one that sent it was authorized to send this kind of type of messages. We want to make sure that the one that sent it is a legitimate user. How do we achieve it? So to the first two, we'll use digital signature, which means that we have a cryptographic key in the sender side that's signed cryptographically on the information, and the receiver side can, of course, validate the truth and the validity of the information by doing decryption or verify the signature. It means that you have a sender that sends it cryptographically, and if anyone tries to change it, it will be detected by the receiver, and then it will discard the messages. In order to achieve the other two, we'll use what's called digital certificate, which means that we have some metadata on the sender side, which contain, for example, who he is, what he's doing, what is capable, if it's authorized, and it's been issued what's called a public key infrastructure. It's actually a back office authority that can issue this certificate to legitimate sender, to a legitimate vehicle, and then the receiver side can validate the signature, can validate who is the sender and is entitled to do it, and that it's coming from a valid source, which is, again, the authority. So what else are we concerned about? This is not enough concerns. So once I said certificate with metadata on the sender side, actually I implied there is privacy issue. Because once you have information about the sender that identifies the sender, and send the location and timing on the vehicle, so actually you are driving on a big tracking device. And actually it can, you can find out exactly what was the route of the vehicle. This is not a desirable feature, okay? We are all concerned about privacy, and we don't want that it will be easy to extrapolate where have we been and what have we done. So one may claim that also a mobile is trackable, which has some truth in it. But first, keep in mind that it's actually illegal in most of the Western world to track cellular. Or in other words, it's illegal to buy and sell tracking device for cellular for the general population. But they are criminal. This is also true. But the more stronger justification is that mobile is optional. No one forced us to bring our mobile that I think that everyone here got. No one forced us to activate it. But in a vehicle, it may be mandatory. For example, on the regulation in the North America and US, now they're working about mandate V2V system in a vehicle and mandate to activate it. And then it's not an optional. And then it's a real problem. So now, again, let's translate it into technical terms. Privacy requirements. So we want to achieve anonymity of the driver. But we have a problem. We don't really want to achieve fully anonymity because the receiving side for safety application need to have some linkage between messages in order to be able to build the vector of the movement on the vehicle side of him. So you need to have linkage between at least two messages in order to build this vector. So we want to achieve pseudo anonymity. It's not a full anonymity, it's pseudo, because we don't need the long-term trackability or the long-term linkage because it's not very relevant to the safety application to know where have you been half an hour. It's also relevant to know where you were in a minute, or maybe 2 minutes ago. So we will change this pseudonym. Pseudo means it's taking the certificate that I mentioned before that actually should identify the sender and actually change it all the time. This is a term that we are using in car-to-car. It's called pseudonym. So we're changing this certificate all the time, so it's not constant identity, it's changing identity. So actually there is a trade-off, because from privacy concerns, we want to change its pseudonym all the time, so it won't be able to track us as much as possible. But the other constraint that it means that you have to have a lot of pseudonym and you need to change it all the time in order to achieve it, whether you have a big storage in the vehicle of this pseudonym or you need to have a connectivity at the back office that actually will set the pseudonym to the vehicle. So there are many constraints from technical perspective, and we are working to find the right balance between achieving the right privacy to the driver and to be able to comply with the technical requirements. And please spare your question to the Q&A part, and I will try to address it. Thank you.
Thank you very much.
Hi, so I'm Cedric. I'm managing consultant at IOActive. IOActive is a company famous for hacking the Jeep a few years ago, where it was a car with a connected system, and basically we hijacked the connected system and we managed to stop the car on the highway. And nobody wants that because it's a safety issue. So starting with this famous research, we've been contacted by a lot of manufacturers and we've been doing a lot of studies. And through these studies, we managed to define a list of common vulnerabilities we find in cars. But first I want to present what is a car, a modern car today. It's a car connected with different devices in the car, different ECUs, that will communicate throughout the different buses, throughout different protocols, but also they will communicate with the outside of the car with what we just saw. So basically, if you're an attacker, your goal is to compromise one of these models, so then you can inject data in the car and take control of the car. Why do you want to do that? You want to do that because maybe you're a thief and you want to steal the car. But there's a lot of other threats regarding safety and privacy. You can manipulate data. You can hijack insecure communication networks like 3G or Wi-Fi. You can compromise the maintenance to the OBD2 ports. And cars now rely on third-party components like open source models. And these models can be outdated. So these threats, they will materialize, they will apply to different parts of the car. They would apply to the embedded devices, the ECUs, the TCUs. They would apply to the multimedia system, the infotainment system, and they would reach the CAN bus. They would access the sensor reading, and they would be able to modify the sensors reading. This can be extremely bad when you have an autonomous car. They can also target driver's privacy. So everything that we've seen in the two presentations before. In this presentation, I want to focus more on how to attack it and what you need to do to secure the car and secure these assets. Every car, I've been around, I don't know if you've been around, but every car now becomes connected. You have the eCall directive next year in the EU. You have a lot of telematics units. You have Wi-Fi in the car. You can plug your phone on USB. You have CarPlay, Android. Basically, your car becomes like a mobile phone. This was the presentation before, I think. So you can connect to the car through different protocols and different interfaces. When you're a hacker, because my company actually is a company composed of hackers, you want to reach out to the car to one of these interfaces and see if you can connect to the CAN bus. If you look at this diagram, the CAN bus is at the bottom, and you want to inject packets. You can use the USB, the Bluetooth, the cellular, or the Wi-Fi, and if you find the right way to bypass the security measures, if they exist, you can target the CAN bus, which means you can do whatever you want to the car. So like I said before, we have a lot of research, we've done a lot of tests, and we've done that for different manufacturers, which means we have an overview of what can go wrong when you develop a car. We talked about 100 million lines of code in a car, so nobody can secure 100 million lines of code. So you need to understand what could go wrong, then you can take measures to protect the most critical threats. There's a report available for free online, and that's the top vulnerabilities. The first one is information disclosure. It means we can extract info from the car. We can get the VIN, which is the unique identifier of the car. And if you got the VIN, maybe you can connect to the backend and take control of the car or extract data on the car's location or on the driver. We noticed also a lot of coding logic errors. That's really simple. When you code, you want to look at the functionality, the car will open the doors when you send a message. The problem is sometimes you don't validate who is sending the message. So any attacker can open your car and steal the car. You're sending the right message, they just don't validate it's you. A lot of buffer overflows, they're similar to coding errors. So basically with a buffer overflow, you can crash the car, and when you crash the car, in technical terms, you can write in the memory, so you can bypass security controls. This one, number 4, is called hard-coded credentials. Basically, that's something we don't want to see in a car. When you buy a car and someone connects to the maintenance port, they can reconfigure the car using, for example, admin as a login and a password. Another one we don't like is also called backdoors. Basically, you have a hidden functionality. Maybe because the developer wanted to have something to access the device and he forgot to remove it. The same, using this hidden functionality, you can take over the car. Vulnerable dependency, you are using third-party components. Least privilege, web vulnerabilities, they are more about bad coding practices. We will go into this one later. All these different vulnerabilities apply to every component of the car. They apply to the telematics communications, but also the CAN bus access. When we say no attack vector, it means it is in a device, but you cannot reach the device. The thing is, with connected cars, this device will become connected, so it will become reachable. Indirect means we have a device that is vulnerable that needs to be attacked through another device. That's what we did with the Jeep. We targeted the infotainment system to reach out the CAN bus. Attacker enabling means this is an attack that will allow you to attack other devices. So 4 and 5, they're correlated. When we say ECU compromise, we mean we can modify the integrity of the ECU. You cannot trust the ECU, which means I can send you a brake signal, and the ECU will interpret the brake signal and stop the car. If we say ECU disabled, it means the ECU is off. You turn it off, which means you cannot even control the functionality it does, which is a safety issue. Hopefully only 1% of these attacks will potentially have a safety issue on the life of the passenger. What I want to show then is how do we enable these attacks? Most of the attacks, they use network traffic. They use either Wi-Fi, Bluetooth, 3G, and some of them they use USB. The last two ones, CAN bus and serial, you need to have physical access to the car. But with the new ODB2 dongles that you get for third-party services, for an insurance, for example, or to track your car, you are actually enabling this attack vector. So if you have this new device, there's a lot around, and you want to track your car, if this device is not secure, and I can tell you it's not, because for 30 euros, there's no security in it, you're actually giving access potentially to your car. So you need to be very careful. However, all these vulnerabilities we found, we're quite happy because only 22% can potentially kill someone or have a safety impact. They're critical. The rest, they're okay. It's not nice to have them, but they will not kill you. If you're an attacker, you want to use the critical and high risk because you want to increase the value of your attack. For example, you want to get a ransom from the manufacturer, or you want to target someone or a certain brand of car. So we decided that we need to fix the critical and the high in priority, and we need to understand how difficult it is to fix them, and we will provide recommendations. And we found actually that it's not so difficult if you spend time to understand what should be done at minimum, and the effort to do that is actually low for 77% of the vulnerabilities to fix, which means if you're a manufacturer or a supplier, you need to invest time to understand what could go wrong and put in place some practices, some good practices to fix it. It could be a training or it could be a technical good practice. Regarding the recommendations, how do you know what to do? There's a lot of good practices. There's ENISA that will present just after me. There's code review, secure coding, and a few organizational practices. But the most important thing I want to emphasize today is that when you are designing a car, when you are providing devices for a car, you need to create security at the beginning of your life cycle. That's called security by design. If you do it, if there's a vulnerability, you will be able to patch it and to make the car more secure. In conclusion, what we found throughout this research is that there's a lot of vulnerabilities shared between the manufacturers and the devices. The industry is going in the right direction. There are solutions. They can apply to other systems. They can be reapplied to cars. However, they must become well used, even though yet they're well known. And we think that this research will allow us to increase the security of current cars before we move towards autonomous cars, where we don't want them vulnerable. Thank you.
Okay, so good afternoon, everybody. My name is Rossella Mattioli, and I want to thank the speakers because they helped me a lot. And so let's try to see how many people know ENISA, the European Union Agency for Network Information Security. Okay, so we have very few, and so I think that you will be very happy to know that we have a study about cybersecurity of smart cars that you can go and download now and use in your risk assessment if you are developing apps or you are developing anything that has, you are OEM, tier 1, tier 2, and you are working in the automotive sector. The European Agency for Cybersecurity is exactly this. We work for you. We work for the operators. We work for OEM, Tier 1, Tier 2. We work to secure European citizens. And European citizens, I believe, use cars. Cars that are going smarter every day. And this is why we do a lot of stuff. We publish studies, and today I will talk about what we published last year and you can already use to set up what is the groundwork for future evolution of automotive cybersecurity in Europe. So just a little bit of overview. As I said, I was very much helped by the previous speaker because they already depicted the threat scenario that you can find on our study. We have an increased attack surface. As you can see, we went through all the incidents and all the proof of concept of the last 5 years. And we're trying to understand what kind of attacks are out there, what can be done to the cars that you drive today. Up to now, we calculated that 100 million cars had to be recalled. So we really wanted to look into all the possible attacks and give you the overview that you can use to understand what is the attack vector inside your asset, and really to help you secure the asset that you are giving to the automotive cybersecurity or as a car globally. Because we truly believe that we really need to put, as Cedric already underlined, security by design from the beginning, and this was not out there up until now. How many of you have the concern of safety? Safety in the automotive cybersecurity is within the culture, is very, very important. We have to have the same attention for cybersecurity and cybersecurity impact on safety. So we really have to create a culture of cybersecurity, not only for the liability issue that arise with going connected, but also because there is a process integration. And the idea of having this study that you can find at enisa.europa.eu/road was exactly this, to set the baseline for future efforts. Because as you can see, you have a lot of attack surface. We already saw many examples in the previous talks about the OBD, the CAN bus. The car can be attacked by many different ways, internally or externally. So the idea here was really to provide European operators and private sectors with a study that covers all the possible threats of the car of today, because we want to make safer car today, secure car today for safer car tomorrow. The idea here was really to give you something that you can download now and you can use today in your own risk assessment. When you develop any kind of asset, any kind of services, any kind of mobile application, everything that has to do with smart. What we do in ENISA is exactly this, giving you tools, studies, knowledge, putting together all the knowledge for Europe that you can use in your business every day to make more secure cars, because we want to secure European citizens. And with 550 million of citizens, we have a lot of work. So this is why we published this study. And also we launched a CarSec security group where we try to group all the major experts in Europe for automotive cybersecurity. Because everything that we do, we want to check with the expert out there to provide solutions that, that solve the needs of Europe. So just to give you a little bit of the attack scenario that we depict, you will find a study that we go step by step. We try to cover the impact, the asset, and also we try to give you the solution. So we list for all the attack scenario that we mentioned before, the one coming from internet, cellular. So when I can enter inside the car and manipulate asset and networks and data stream, or when I can directly connect with the CAN bus and ODB. We depict all the different steps, the impact, all the different factors that can provide compromise, and also we try to give you an idea of what you can already put in place to secure this and to prevent this kind of attack scenario. We defined the attack scenario based on the interview we had with the expert. Those scenarios are those that were defined as the most critical, the one that can have an impact on the life of the citizen or mass impact. But as I said, we do not only depict what is the threat landscape. We also try to give you solution, because we try to go through all the possible incidents of attack, and then also to all the possible good practice, standard, and everything that is available on the internet, on the different standardization body, regulatory body. We try to really to map all the existing literature and available knowledge base for security measure and map them together to help you and give you something that is useful for your work, to give you solution that you can use in your everyday work. And this is free, available on the website, and we really need for you to tell us what you need. Because, as I said, ENISA is the European Union Agency for Network Information Security. We were established to provide expertise to the private and public sector in Europe, but also to be the advisory body for Europe, European Commission, European member states for future steps. So, as you can see in the study, we depict the threat landscape, we give all the good practice, but also we give recommendations for Europe. And cybersecurity by design is the first one, and this is something that we are promoting over the years, not only for automotive cybersecurity, but for all critical infrastructure. Moreover, we really need to improve information sharing. At the beginning of this talk, I asked how many people know ENISA, or the fact that we have a study out there that you can use today, and only few people raised their hands. We really need to improve information sharing, because we know attacks, we know incidents, but we know also how to mitigate them. So everything that ENISA does is really to facilitate knowledge transfer in Europe, to put everybody around the table, because we have this unique opportunity since we are the European agency, and really try to answer the needs of cybersecurity for Europe. Finally, we have the last two recommendations. There are more and more detail, and I invite you to go to the website to see. Achieve consensus in technical standards for good practice, because, as I said, in the study we went all mapping everything that was out there, and we really need to discuss and achieve consensus, and also clarify the liability. We talk a lot about liability. We don't have an answer, but for sure we need to discuss and to find a way for Europe, for European citizens, to understand where it finishes and when it starts. So, as I said, ENISA role is to be the advisory board, the expertise hub, the information sharing facilitator for Europe. We deal with all the member states, with all the operators, and directly with the European Commission. This study was focused on the cars of today, the cars you drive, and the cars you are designing up or solution or are designing now. And you can use it now as you go back to your office. But this is also the base for what we were talking before, the connected car, the car of the future. So we need to secure the cars that are out there now for safer cars tomorrow. I invite you all to go to our website, because you will find that not only we have studies about the cybersecurity of smart cars, but also, for example, we have a study about mobile software development. We provide trainings, and also we really try to understand and depict all the possible spectrum of cybersecurity challenges in Europe. So we cover topics from encryption, from cybersecurity challenges to trainings, to cloud, many different aspects that are all involved in the automotive cybersecurity. So it's really important for you, if you don't know ENISA, to take advantage of what we provide you. We publish around 70 studies a year, and we organize around 50 events all across Europe. So this is a great opportunity, wherever you are, to engage with us and tell what you need to make more secure cars in the future, or more secure cars today. Thank you.
So let's start with the conversation. Threats and vulnerability, I think, a common theme through all of your presentations. Yoni, when talking about connectivity, how do you create in that environment? How do you create trust? How do you make sure you can trust your partners to work on safe and secure solutions?
So this is a good question, because as I was explaining in the review, the benefit of the receiver is depend, of course, of the sender, the reliability information. And even if I, as a vendor, do all the security measure in order to provide it, it's only about what the other vendors did. So in order to do this, we need to have a baseline security quality assurance that is agreed, consensus by all the stakeholders, and that we are actually need to stand with any vendor that want to play in the game. And we are working on it. We are actually defining what's called protection profile that defines the security requirement, the security quality assurance that is required from each one that participates in the system. And the back office, the PKI, will issue certificate and cryptographic information only for those who comply with these requirements. And then me, as a receiver, in my place as General Motors, will know that you receive messages only for players that actually stand with the relevant security requirements that we all agreed about.
Thank you very much. Rossella, anything you would like to add in terms of ENISA supporting that creation of that trust and the role of ENISA in bringing those parties together?
Yes, exactly. One of the things that I want to stress is exactly this. What we do as a work is to provide input and synergize and provide the ground for future efforts. So this is why we really need to cover the actual situation to give then the floor for development of future efforts. What we defined in ENISA last year was exactly smart cars today for autonomous cars tomorrow, because this will be an input to the CITS platform that is defining the future of the car in Europe. So we wanted to secure what is out there now to provide them an input for what will be the future. And we really need to secure the current attack surface, because we cannot build a future autonomous car, connected cars, without mitigating what is already out there.
Thank you very much. Speaking of future, Cedric, it was really profound seeing the facts and figures of where the vulnerabilities are today, where the attacks are today. We know that the world is changing and changing faster than ever. Where do you see the trends going in the future?
So the thing is, there will be more and more software, more and more connectivity in the cars. What we noticed throughout this study is that the vulnerabilities, the top vulnerabilities, are more or less always the same. So with a certain list of measures that you can apply across the sector and across the different suppliers, then you will be able to secure the car better. What we also notice, my company is actually doing penetration tests, which means we hack the stuffs. And we notice more and more suppliers and OEM come to us to test the device for security. And more, when we find issues, they develop the countermeasures in the product. So that's what I call security by design. So I think there's now an awareness. We are seeing also more and more discussion in the community, maybe soon some standards. So I think it's really important that people are aware of what to do, and we're going the right way.
Okay, thank you. With all the best efforts of making things ever in terms of prevention and making everything very safe and very secure, the incidents do happen. So Yoni, when a system is compromised or has been compromised, what should happen next?
Yeah, so first I didn't mention, but car-to-car consortium is actually try to gather the different OEM, different stakeholders in the market, and actually my colleagues there are actually members in this consortium because we need to get consensus and we need to get to standardized solution because actually it's not standalone system, it's ecosystem. So, and the same question goes to what happened when system compromised. We need to have a consensus between the stakeholders, including the CATA, the EU Commission, about what will happen when a system has been compromised. So actually, currently there are two methods how to address it. One is what's called certificate revocation list, that once it's been identified that the system was compromised, the vehicle was compromised for many reasons, then there is a central authority, for example, maybe operated by the EU Commission, that can actually revoke this vehicle and send the certificate revocation list to all the other vehicles. Of course, it's very challenging because how to distribute the information, how to make sure that everyone receives it, But this is one approach. Other approach, I said that in order to get the system work, you need to have the pseudonym. And the pseudonym should be issued by the back office, by the PKI. So if you limit the number of the pseudonym in the vehicle itself, and the vehicle have to request more pseudonym from the back office from time to time, then actually the back office can not issue a new certificate for a compromised vehicle. So if you limit the number of certificates for a short period, then you know that this threat is limited by time.
Thank you. Marcus, you gave us an example. I will not forget that safe, that yellow safe. I don't know how about you. A very visual example of, I wouldn't have ever dreamt of doing this to a safe. So I think if you look at where do the risks come from, there are as many as we would normally think. So that was a moment for me where I said, well, actually coming from somewhere, literally, where I would least expect it. How do you approach the security evaluation? Because fundamentally, it all starts with identifying which areas do we need to look into, isn't it?
Yeah, indeed. And by the way, also it's, as mentioned before, today is a facing challenge that the automotive systems get more and more complex. And so from this perspective, I think it's not manageable task if you want to get the security evaluated from a complete system like a car. So many components are interacting in here. And so I fully agree also that it's important that every component itself is already fulfilling the requirements, not only functional-wise, but also security-wise. And therefore, I think it's very important that this will be also evaluated independently. So as we have heard also before, some penetration tests, some testing has to be done on those components in order to check out whether there are some weaknesses which may endanger the security of the complete system. And so I think especially by common criteria, very often it's called, well, there's so much overhead and so on. But I think here we have also some benefit because a manufacturer undergoing such a common criteria certification does not only get the feedback where are some weaknesses, but he also gets the feedback where he have done the security in a right way or even have to implement too much security. And so he can leverage this over the complete system that he do not spend too much security in some components, but in the end there are some components which are so weak that this is the easiest way for the attacker. So I think such a deep evaluation on all the components and therefore getting the security of the complete system, this is something which is today missing.
Thank you. With the complexity of the system itself, with the number of vendors, with the number of parties involved, there's an interesting example from looking at the past and looking at where the liabilities lie. We probably all remember the Ford Firestone case, early 2000s, where, and again, the regulation was very slow, and there was almost kind of, there wasn't that pace of movement and a consensus and agreement. After that case, the accident fatality where it was unclear whose responsibility it actually is it Ford or is it Firestone? The US government came up with the Threat Act, with the regulation that required every car manufacturer, so that put a very clear liability for reporting and for making sure that there is safety, physical safety. We're now talking about cyber and safety in digital way. So do we need a shake-up to actually, and all of a sudden, and it is within 2 years, and they had to implement it. There was no negotiation. It was no democracy, no consensus. Do you think we can learn from that? Do we need a shake-up, or are there smarter ways of getting to that stage where there's clarity and consensus?
As I said before, we need to talk about before the shake-up, because we cannot, we are talking about safety, we are talking the life of the citizen, especially from an ESA point of view. So this is why we work on smart cars, because we need to bring all the OEM, Tier 1, Tier 2, all the involved parties around the table. We need to discuss about liability. We need to discuss about security measure, because if you really wanted to go on the autonomous car 2020, all these different challenges that we are going to face, we really need to be prepared. And we don't have so much time, because I'm very familiar with attackers, and attackers cannot wait to have all this attack surface. As it's shown us, it's very, very easy. It's like everything, we can think about all the details, but they will find a way. So this is very important for us to discuss all of this, to discuss liability, to discuss standards, to achieve a model for information sharing, to start get ready to respond quickly. You said years. We need to respond quickly, because when we will have entire smart cities, life of millions of citizens at risk, we will not have the time to talk about it.
But I think there's already some motion inside the car industry. So when I monitor all the different behaviors at the OEMs, I see that there's also some awareness for security. To be honest, I think it's a very challenging task at the moment, because if you look to the car electronics, in the past there has been only very simple systems. And nowadays we have seen in several block diagrams there are very complex systems, and they typically build up with components not focusing on security. Now they have the situation that they have somehow to implement the security, and of course it's much more difficult than implementing the security by design. But I have the feeling that the car industry is already wake up, but it now takes some time, and of course it would be good if it's increased in terms of speed, that it's faster, more secured, but anyhow I see very good signs that there's already some movement in there.
Okay. Thank you very much. Thank you everyone. Marcos, Ioni, Cedric, Rossella. Thank you too. We carry on at 1500 with the afternoon sessions. Look forward to seeing you there. Thank you. Thank you. Applause for the panelists. Thank you.